Alright guys, we're back to this setup with the tape wrapped around the magnet. Now, as we've seen in previous tests, the water would spin one way, or the water and the bubbles would be forced in one direction, and when we allowed the magnet to spin without the tape on it, of course the magnet would spin in the opposite direction, equal and opposite forces. Now I thought I noticed something looking at the video a little closer. When we first start this motor up, it looked like the bubbles were spinning in one direction and then the magnet started to spin in the same direction with the tape on. So I'm just going to let you have a look at this yourself. It would seem there's something different going on here, and I would say that it seems like it, and I'll show you what I mean. So I've got my power supply set at 9 volts at the moment, so the magnet won't spin, and I've got a meter here just set on DC volts so you can see. So I'm just going to switch the power on, and as you can see there is a very clear clockwise spin, and I'll be keeping the clockwise and anti-clockwise the same throughout the videos, and that is in reference to looking down on the top of the magnet. So you can clearly see that that is spinning clockwise, 8.6 volts in there, and a definite clockwise spin. So one would imagine that the magnet would spin anti-clockwise. So what I'm going to do now, I'm going to turn the voltage up. That's 10 volts, 11, oh, push the wrong button, 12 volts. Now you can see that the bubbles are definitely spinning clockwise. We would expect the magnet to go anti-clockwise. 13 volts, oh, and there we go, that's 23. I just hit the wrong button, but it jumped up. Now you can see that the magnet is now spinning clockwise as well. I'll try and slow that down again a bit. Take it down to 17. What I'm trying to do is slow the magnet rotation down. Okay, that's 14 volts. I don't know how clear that is. So that light's a bit of a pain in the butt, isn't it? I'll put it down the back there or something. Just trying to get the best light possible. I don't know if you can see that the bubbles and that are spinning in the same direction as the magnet, but are leading it. I might just turn this voltage down again so we can get it to stop. So now you can see that the vortex of bubbles is spinning faster than the magnet. We're at 10.59 volts there. The magnet's almost stopped, and the vortex is spinning a lot faster. So with the tape on the magnet, the vortex on the magnet's on top of the magnet, the bubbles, and of course if the bubbles are spinning, the water must be as well to carry the bubbles around, as you can clearly see there. So with the tape wrapped around the magnet, insulating the side of the magnet, the bubbles spin, or the vortex spin on the magnet, is in the same direction as the magnet spins and not opposite. So what I'm going to do now is I'm going to remove the tape and have a look, because there's a very good chance I had the magnet upside down the other time when I was testing it, and we may be looking at the bubbles spinning in the same direction as the magnet, which is without the tape on, which is a test we actually haven't done yet. But this test with the tape on, the vortex is spinning the same direction as what the magnet spins with the tape on the side. So we'll take the tape off now and we'll have a look. I'll be back shortly. Alright, what I've had to do is get a screw the same size and grind the top flat, because the magnet just wanted to spin even down as low as 3 volts. So it's fixed now, it's not going to spin because we've ground the point off of the screw. Now that magnet is up the same way. All we have done is remove the tape. I'm set at 22 volts on my power supply. I'm going to hit the button and show you what happens. As you can clearly see, without a doubt, we now have an anti-clockwise spin. So with the tape on, we get a clockwise vortex on the top, and the magnet spins in the direction of the vortex. And without the tape on, we get an anti-clockwise spin vortex around the magnet, and the magnet spins clockwise. So the vortex that can only mean the vortex or the spin on the top of the magnet is opposite to the spin around the outside of the magnet, which is quite interesting. So I'm not sure if this is just in the case of the water, or with all homopolar motors it would seem that we have 2 different spins happening, and one would be fighting the other. So I've pretty much well filled the fish tank up with water, with bubbles now, and we can't see. You can definitely see a very rapid anti-clockwise spin, and the magnet will spin clockwise, and with the tape on we get an anti-clockwise, a clockwise spin, vortex spin on the top of the magnet, and the magnet still spins clockwise. So we've got 2 different spins happening in this setup here. So I'm not sure if it's going to be the same with a homopolar motor, standard type setup, out of water, but in water we definitely have 2 spin directions opposite. One large one around the outside of the magnet, anti-clockwise, and one on the top of the magnet that is clockwise. And that magnet is up the same way, and you can quite easily test that at home for yourself. A definite anti-clockwise spin. Very interesting. I think there's a whole lot more to this than just the regular rules and regulations you read out of books. But it doesn't come much clearer than that. Once again, the outside of the magnet we get a anti-clockwise spin, and on the top of the magnet we have a clockwise spin. And with or without the tape on, the magnet will rotate clockwise. Interesting stuff. Thanks for watching, guys.